This time we're supposed to find the currents in the circuit without using Ohm's law. Okay, so what we're supposed to do? Let's use common sense. We have resistor R1. Okay, by this resistor, current 10 milliamps will flow. Okay, let's take a look at resistor R2. Resistor R2 is 4 times greater than resistor R1. So it means that current I2 is going to be 4 times less than this current. So I2 is going to be equal 10 milliamps divided by 4. 10 milliamps divided by 4 is equal 2.5 milliamps. Okay, so this is the current which will flow through the resistor R2. Now if you want to find I3 is basically 10 milliamps divided by what? 16, because this resistor is 16 times greater than this. So my current is going to be 16 times less than 10 milliamps. So I'm going to divide this by 16. Okay, so this is equal 10 exponent 3 negative divided by 16 is equal 625 microamps. Okay, and if you want to find I4 is equal 10 milliamps divided by what? By 20. Okay, so this is equal, okay, this is very simple, this is 500 microamps, but let me show you how we do this on the calculator. We have 10 exponent 3 negative divided by 20 is equal 500 microamps. Okay, now we're supposed to find I total. This is going to be my I total, and this is also my I total. Okay, because the current which gets into the circuit and current which leaves the circuit must be the same. That's why I call this I total, and this one is also I total. So I total for the parallel circuit, this is KCL, Kirchhoff current law, is simply I1 plus I2 plus I3 plus I4, and this is equal 2.5 milliamps plus 625 microamps plus, I forget about I1. I1 is equal 10 milliamps. Okay, so let me write this down over here. This is 10 milliamps. Okay, so this is my I2, this is my I3, this is my I1, and this is my I4. I4 is equal, no, this is plus 500 microamps. Okay, this is equal. Let's check how much this is going to be equal to. Okay, so we have 2.5 exponent 3 negative, this is my 2.5 milliamps, plus 625 exponent 6 negative, this is my 625 micro, plus 10 milli, okay, plus 500 exponent 6 negative. This is equal 13.62 milliamps. Okay, so basically we found all currents without using Ohm's law, and these are the solutions to my problem.